So, looking at volume of similar shapes, we'd be using the volume scale factor to find the missing volume, and then we'll also be using the volume scale factor to find missing lengths. So, in this example here, we've got a cube 3 by 3 by 3. We're going to double those lengths, so the length scale factor is 2. So the lengths become 6, 6, and 6. And the volume of that cube now is 216 cubic centimeters. The scale factor for the volume, i.e. how much has the volume changed? Well, from 27 to 216, that's 8 times. So when the lengths have doubled, the volume is 8 times as much. Let's see why this is. If we write 6 centimeters as 3 centimeters times 2, i.e. the original length doubled, and we do that for each of the 3 lengths of the larger cube, and then we try to work out the volume from those lengths, we end up with 3 centimeters times 2, that's the base there, times by the depth, times by the height. So that's just 6 times 6 times 6. But within that, we've got 3 centimeters times 3 centimeters times 3 centimeters, and that is the original volume of the small cube. In addition to that, we've got times 2, the length scale factor, times 2 again, the other length scale factor, times 2 again, a third length scale factor. So we end up with 2 cubed. So the volume is 8 times as much. That's the original volume, and that is the volume scale factor, the length scale factor of 2 cubed. And that gives us the 216 from our larger cube. Let's apply that then in this situation. We're trying to find the volume of the larger cuboid. The length scale factor is from 5 to 10. That's a scale factor of 2. And we're going to cube that for the volume scale factor. So the volume scale factor will be 2 cubed. That's 8 times as much. And 120 times by 8 is going to give us 960 cubic centimeters. Here's another example. Doesn't matter what the shape is. The length scale factor, we've gone from 10 centimeters down to 5 centimeters. So that is a scale factor of a half for the lengths. Therefore, the volume scale factor will be the length scale factor cubed. So that's a half cubed. So we're going to be multiplying 200 by a half cubed. And that works out at 25 cubic centimeters. This time we're going to be finding a missing length given the 2 volumes that we're going to be given. And in order to do that, the length scale factor is the cubed root of the volume scale factor. We've been saying the volume scale factor is a length scale factor cubed, so that must mean the length scale factor is the cube root of the volume scale factor. So in our example, the volume has gone from 100 to 800. That's a scale factor of 8. The cube root of that will give us the length scale factor. So the cube root of 8 is 2. And so if we multiply 6 centimeters by 2, we're going to find our new length, which is 12 centimeters. Once again, doesn't matter what the shape is, volume scale factor from 2000 down to 250. 250 divided by 2000 is 1/8 or 0.125. We want the cubed root of that, and the cubed root of 1/8, the cubed root of 0.125, that is going to be a half. So the lengths are 15 times by a half, and that will be 7.5.